In this section, we're going to be looking at asymptotes, vertical and horizontal asymptotes, and we're just going to limit our notes in this section to just these two examples right here, identifying horizontal and vertical asymptotes. There's a lot here, and so want to make sure that you really understand it before we move on to notation or anything like that. So the first thing we're going to do is we're going to look at this first function here, 2x squared divided by 4 minus x squared. And we type that into our calculator and we graph it. And up until now, we've been looking at graphs similar to this and just assuming that we have an asymptote. So if I just look at this and glance at this, it looks like that as I move along the x-axis, going from left to right, approaching positive infinity as it increases, it looks like I could possibly have a vertical asymptote at -2 and another one at +2. I'm just kind of right now assuming that. I could go to my table and see that I'm getting closer and closer to -2 and 2, never touching it. I could do that, but I still, have a little question in my mind, is it really? And then also, it looks like there could also be a possible horizontal asymptote here as well at maybe -2. Again, a big question mark in my mind. So what we're going to be doing in this lesson is verifying that algebraically. So first thing we're going to do is we're going to set aside our graph and we're going to look at this just algebraically. So first off, we're going to know that if there is a vertical asymptote, we can find vertical asymptotes using our domain restrictions. A vertical asymptote is found by first finding our domain restrictions. And if you remember that, it has to deal with our value in the denominator and value underneath a radical. So I look in this particular function and I do see that I have a variable located in the denominator. So what I'm going to do first is I'm going to take this function and put it into standard form, meaning I'm going to get the highest degree out in front first and rewrite it. So I just brought the -x squared out in front, plus 4. Now, we like to remain positive with our leading coefficient, so I'm going to factor that negative out, and I get x squared minus 4 under the denominator with the -1 factored out. Factoring out the -1 changes the positive to a negative. And if you want to double check your work, you always take your factor that's out in front, multiplying it to both terms inside, and you should end up with what you had to begin with. Then, recognizing that I do have a difference of squares, I want to factor that, and we talked about that as well, that if we can, we want to factor anytime that we can. I think that was when we were talking about a whole, that if we could cancel factors in the numerator, also with the factor in the denominator, we have a whole. So we know that x squared minus 4 factors into x plus 2, x minus 2. That is a difference of squares. The x times x gives me x squared, and -2 times +2 gives me my -4. So I look at this, and I don't see a whole because there is no x plus 2 in the numerator, and there's no x minus 2 in the numerator. So none of that applies in this particular function. So therefore, I would say there would be no whole. But what I do see is a restriction in the denominator. X plus 2 and x minus 2, both of those factors contain a variable. So therefore I know that x cannot be, looking at the x plus 2, I know that if I plugged in -2 here, I'd get a 0. Can't have that. And if I would plug a +2 into this factor, I would get 0. I can't have that. So therefore I know that x cannot be -2 and x cannot be 2. If I go to my table, that same function, I will see an error at -2. I will also see an error at +2. That just verifies that the work that we did here finding the restrictions is correct. And not only do we have a restriction at -2 and 2, but what we have also found, and you did not know this as we were going through, is that we have also found vertical asymptotes at -2 and 2. And so when we looked at the graph, we could see Yes, as a matter of fact, that really does look like a -2 vertical asymptote and +2 vertical asymptote. We verified it on the numerically, and now we have verified that graphically. So vertical asymptote, to find a vertical asymptote, we look for our domain restrictions, and there they are. X cannot be -2, X can't be 2. Now, on the graph, it did look like there could be a possibility of a horizontal asymptote. Well, we're going to find that and prove that algebraically. Now, with that, you're going to need to remember something kind of silly, but Mrs. Meyer does things a little silly anyway, so that should not come as a surprise to you. To find a horizontal asymptote, you're going to use something called BOBO, BOTN, eats DC. BOBO, BOTN, eats DC. There are 3 situations that we can occur finding a horizontal asymptote, and they all have to do with exponents. So once you get your numerator and denominator in standard form, doesn't matter the degree, it just needs to be from greatest to least going down in standard form, or looking at our degree. And I do have this in standard form. So now I look at the degree on the numerator, which is the highest exponent, that's a 2. I look at the degree in the denominator, highest exponent is a 2. I notice that these exponents are the same, and therefore I'm going to go to one of these categories where I have exponents are the same. That would be the acronym eats DC. So if the exponents are the same, I divide the leading coefficient. So my horizontal asymptote, to find the horizontal asymptote, exponents are the same. That's my eats. So then I divide coefficients. So my coefficient is 2 divided by -1, and I'm using the function when it is written in standard form. So I'm taking 2 divided by -1. It is not 2 divided by 4. It needs to be in standard form. So 2 divided by -1 is -2. Therefore, I have a horizontal asymptote at -2. Now, if I want to write this in interval notation, I have to include all of my my vertical asymptotes, because remember, this is going along, domain is going along the x-axis. So when I'm writing domain, I'm writing it in terms of my vertical asymptotes. So my vertical asymptotes are where x cannot be -2 and x cannot be 2. So it's all other real numbers except for -2 and 2. So writing my domain, it's all inclusive. So I start with all real numbers, -infinity to infinity. I'm plucking out -2 and I'm plucking out 2. So it's all real numbers except for -2 and 2. Looking at your table, you would see that. So as a refresher, to find a vertical asymptote, we look for domain restrictions. Is there a variable in the denominator? If so, set that equal to 0 and say it cannot be, and solve for x. Is there a number under the radical? We would do the same thing, looking for that restriction. Horizontal asymptote is the acronym BOBO, BOTN, eats DC. BOBO stands for big on bottom. My horizontal asymptote would be 0. So if the degree on the bottom is bigger than the degree on top, I automatically have an asymptote at 0. If the degree, this one's big on top, there is no horizontal asymptote. So if the degree is bigger on top than it is on the bottom, I have no horizontal asymptote. Okay, let's look at the second example, g of x. I will type that into my calculator as x divided by quantity x squared minus x minus 2. And I graph that. And let's just eyeball it, looking at the graph. Looks like I might have a vertical asymptote. Let's see, maybe at -2, or excuse me, -1, and possibly at a +2. Maybe a horizontal asymptote at 0 here. But let's now apply what we've learned and verify that algebraically. So the first thing I ask, is the numerator and denominator in standard form? And the answer is yes, my degrees are going down. Next thing I want to ask, is it in factored form? Denominator is not in factored form, so I need to factor x squared minus x minus 2. I first ask myself, since the leading coefficient is 1, two numbers that multiply to give me -2, but add to be +1. And I do believe that to be a -2 and a +1. So two numbers that multiply, you can use a little diamond if you wish. Two numbers that multiply to give you -2 but add to be -1. -2 times 1 is -2. -2 plus 1 is, that should be a negative, is -1. So those two factors immediately fill into my parentheses, and I can do it that way since that leading coefficient is 1. Therefore, I see I have a restriction, and at that restriction, x cannot be 2, because if I plug 2 in, I get 0, and here x cannot be a -1, because I would plug 1 in there, and I would get 0 as well. So those are my two restrictions. That confirms my suspicion here at -1 and 2 when I look at it graphically. And if I would go to my chart, sure enough, -1 and 2 are where the arrows or the errors occur. So I know that I have a vertical asymptote at x equals -2 and x equals -1. Now let's check our horizontal asymptote. I look at that using my BOBO BOTN. So remember, BOBO stands for big on bottom, horizontal asymptote automatically at 0. Big on top, if my degree is big on top, I have no horizontal asymptote. And if the exponents are the same, then I divide coefficients such as what we saw in the first example. So I look at my degrees here. The degree for x, there is not one given, so that's an assumption of 1. And the degree on bottom is 2. Remember, it's the largest degree. It looks like that I have the big on bottom. My degree in the bottom is larger than the degree on top, so it's big on bottom, so I automatically have a horizontal asymptote at 0. That would be y equals 0 then. So I write my domain, excluding +2, sorry, that looks like a negative there, but that's actually a +2, and -1. So my domain goes from -infinity to -1, union with -1 to 2, union with 2 to infinity. So as a recap, vertical asymptote is our domain restriction. X can't be 2, x can't be -1. There's my vertical asymptotes. My vertical asymptotes get written into my domain because it's as I go across the x-axis, where do I jump over? I jump over -1 and I jump over 2 and moving on. My horizontal asymptote is used finding my BOBO BOTN, EATS DC, just a little silly acronym that was created to help us find the horizontal asymptote. And it's only looking at the degrees. If the degree is big on bottom, then it's going to gradually approach 0 from both directions. And you can see here on the left it approaches 0, and over here it approaches 0. When we have a graph that is split in the middle, such as this, the left and right asymptotes kind of take over that. We ignore that 0 where it crosses when it comes to finding a vertical, coming to find a horizontal asymptote. So we can still record this as the left approaches -infinity, as the right approaches +infinity, because that is the behavior of the graph as it's moving to the left and as it's moving to the right.